Welcome back to the lab. Yep, I made a lot of noise last night. The pile of swarf got much larger. Actually, a lot of that's aluminium swarf because I sort of cleaned up the lathe. It's a new day, start with a clean machine, right? Clean machine, that rhymes. So yesterday we got this end done. You can smash that into the tube. Smashed. I mean, I did use a hammer, not that hammer. That hammer, so you don't damage the end. This one's already damaged and I have to fix that up. Yeah, that's my fault. Never mind. So we got this one in there. This one here was a bit harder because of stuff and things, reasons. And I actually took that down a little bit further than what I had done in the end of yesterday's video. I took the original tube completely off it so that we just got a bush. And we've now got to turn down that bush so it fits inside this tube, and obviously not at this point in the tube. It's going to be about there. So that's our drive shaft there, our prop shaft, which is, I'll put it this side, which will make it hard for us. As you can see, that is going to be just a bit longer than what the original one was. Bearing in mind one of these joints, which it was probably this one, actually went straight onto here. So that's the difference basically in length between the HGT Precision 5-speed sequential box and the, I can't remember the number off the top of my head, it's like RS5030A or something along those lines. Yeah, someone's going to correct me because I got it wrong, I don't care. The 2-wheel drive 5-speed late model YD25 powered D22 Navara gearbox. There you go. So they're quite a bit bigger box. They were, I think, 70 something kgs, and the HGT one is in the range of 30 something kgs. So they handle heaps more power and they're smaller size, so it's all good. But I digress. The point is we're making a drive shaft and it has to be a little bit longer. So we'll put it back on, put this back, that back onto the machine. I did this part on the 3-jaw because we're going to turn down the outside diameter of it anyway, so it doesn't matter if it's not quite 100% concentric. So we'll put the 4-jaw back in, run it in the center. See that little hole in the middle there? That's spigot. Oh, it's going to be difficult to do. Onto the, somewhere there. That's really hard to do through the screen. So then you know that end's running through and it's held nice and safe and secure, and you put the other end in the 4 jaws because you can adjust the jaws independently. A 3-jaw chuck like this, some of them are independent rather, but most of them operate, all 3 jaws will operate at the same time. When I turn the key, they all come in towards the center at the same time. The problem with that is accuracy is not that great. They can be out by a little bit, and it depends on how fussy you want to be and how good your machine is, etc. But this one can be out by 0.1 of a millimeter off center, so you could put something that's perfectly round in here, crank up the chuck, put the DTI on it, and it's got run out. It's going round out of center by 0.1 or more. I've got something that's perfectly round. Shall I show you? Let's do that. Rightio, we've got our tool. We'll call it a tool for this morning. Hopefully I didn't put it too far into the chuck and screw myself up so I can't get the DTI onto it later. But it's not set on 0. I should have set it on 0, but there is less than 0.002 or something like that of run out on that as far as axially, right? Oh no, it's not axially, longitudinally. Yeah, it doesn't have any wobble going on like this, right? So this face here is true. So now we're going to shift this and we're going to measure this, and we're going to see how much run out it has this way. Alright, so we are on a little bit of an angle there. That's not ideal. We're not getting an accurate measurement, trigonometry and all that sort of carry on. So that needle's going to read slightly more than what the actual run out is on this. There you go. It's a tiny bit more than 0.1 of a millimeter. Like I said. So if you're trying to machine something like this, if this was a bit longer, right, and we machine all this side of it, then we take it out, we flip it around, we put it back into the machine, that combined run out, that could be up to 0.2 of a millimeter of run out, which is starting to get up there. That's quite a bit as far as drive shafts and things like that. You don't want it as high as that. Although in the old money, I think 0.1 of a millimeter is 3 thou or something like that, or a bit more than that maybe, but 40 thou is about a millimeter, so 40 thousandths of an inch. That's why I prefer metric rather imperial. Not perfect, but pretty good. That's acceptable. And I've run that there, there, there. About the same error the whole way. What was it? 0.02 of a millimeter. So that's fine. That is gold. Beautiful. Ready to go. Nice and concentric. I even took a little bit out of the inside edge of here to make it a little bit lighter. But that's, like I say, it's ready to go. Car's back up in the air. We'll measure everything up. Mock it all up. Mark it. Double check. Triple check. Cutting time. Alrighty. So double check the measurement on the car. I've actually shortened it up by... Wifey's cutting trees down again. Shorten it up by 5mm to give us a little bit more fat with our... I've lost my aluminium. Where's my aluminium? Oh, there it is. With our adapter we have to make for the transfer box. So, mocked it up. This is a fixed joint, as in it's non-plunging. And the other end is a plunging joint to give us room in the for flex and chassis and everything. They actually quite a lot of travel. So, and then just marked it all up, lined it up and marked it. That is actually plunged a little bit when I picked it up. And that's our line. Cut there. And then we'll take it in, I think, to mark at ATL balancing and drive line. You can true that up on his lathe because my drop saw is going to cut it crooked. Smack that in there. Weld it all up, balance it, done. I'm possibly overdoing the time I'm spending on this, but never mind. So it's not 100% perfect, but we're just under 0.1 of a millimeter of run out on the shaft there. This is all clocked up 0.02 or something like that. It's very, very close to 100% perfect. You can see how much the needle wobbles around just from the play in the carrier or the travel or whatever you want to call it on the lathe. So going as far as we can go without shifting the DTI to a different spot, which wouldn't be a problem. And we've actually got just a tiny bit less play, run out, sorry, at that end. We're dealing with whatever that is, 0.06 of a millimeter. And you'll get more inconsistencies with the actual tube diameter than that. The tube can have slight ovality, be slightly out of round. So that's good. That's going to clock up fine. I can be brave and try and weld it myself, or we can take it to ATL, give it to Mark and say, I have clocked that up, it is possible. And away you go and weld it. I know that when if I TIG weld this, it moves, guaranteed. It will have run out. I know it does. You've got to tack weld it multiple times and tweak everything, get it in the right spot, and then you can run your weld around. It's very, very hard to get it dead right. MIG welding, much, much easier. You knew I was going to get brave and do this, didn't you? Success though, or relatively successful. What's that, 0.02 can't see it through the camera. 0.06 run out. It's probably a little bit less than that actually, to be honest. It's discrepancies in the tube surface. Is that still... yeah, it's still in contact. Not making as much noise at that end. Dampened a bit. Less run out there. So that's not bad. Good size, as they say on the rock. Now I've only done one weld, because if you do the other one and it moves, dun dun dun. But I reckon I'll give it a go. I'll tack weld it in like 6 places, and if it's still lined up, I'll buzz it on, do the whole lot, and then we'll swap her around and we'll do the other side. Now this end is going to be a little bit harder. Little bit of play there. That's 0.03 of a millimeter too small. Whoops, my bad. It was on size when it was hot, when I was machining it, and then when it cooled down. Oopsie. It's not terrible. I think it'll be okay as long as I'm careful with the welding. Do the same as what I did with the other end. It's actually the bush to the tube that's a little bit loose. So if I do the bush to the tube weld first, the other one's nice and tight, so if I move it, it'll stay where you put it. Alright, that's completely welded up. It's had time to mostly cool down, a little bit hot to touch still, but here's at the extreme end of the shaft. What's that? 0.1. Yeah, if you take into account that little dip it does there, which is in the tube, I would say, not in the actual... it's a funny little dent in it, basically. I'd say we've got 0.8, realistically. Sorry, 0.08. 0.08 of a millimetre total run out over the entire length of the shaft, assuming that's fixed, which it isn't. That runs in a CV joint, so any pivot here is negligible. That's good. That is, I'm going to call that perfect. It's going to be really, really hard to do better than that, even MIG welding it. So, stoked. Now we're going to do this end, which will be a little bit harder. Oh, and these are all loose, right? Here's the shaft wriggling. I'm not cheating and holding it with that to make that run true, which you could do if you were that way inclined, but I'm not. You should be able to see air in between those, so cool. Alright. Is anyone surprised that it took far too long? I'm not. Gee, that's bright, isn't it? There you go. I can't do that with... this is hopeless. Wait 1 second. We'll put it in the shade for you. That's pretty good, isn't it? It's not quite to 0. It's 0.02, I guess. There's a bit of a flicker there, and it goes to is it 0.05? So we've got 0.03 of millimeter run out. It is a little tiny little bit more here, but it's not significant. The other end has not moved. It's still good, but that's not being supported by those. Can we see the air gap? I'm wobbling while I'm trying to turn that. That's running. Look, it's perfect. So stoked. That saves poor old Mark having to do that. Now we need to assemble, balance. I'll scrub these marks off. That's a high point. That's from when I was trying to figure out to get it all lined up. I'll scrub all those off, figure out where the high point is and where the low point is, and then when we assemble it with the CV joint and everything, remember this had 0.1 of a millimeter run out, we'll offset that with the shaft. So if this is too far this way and the shaft's too far that way, we'll put those two lined up like that and it'll cancel out and it'll get it even better. It'll be good. Yay. Awesome. That's looking good. Right, I need to go and see our mate Mark at ATL. We'll get one of these. got one somewhere. There's my old one. Actually, if he's got a pair, I'll buy a pair, because then the thing's going to look much nicer. And they'll be brand newbies. Give him that back. That back. You can put them in the stash of Nissan bits and bobs. We get this thing assembled. Bad news, didn't have the boots that I wanted. So there's 2 ordered. This one's tidy enough, I'll use this one, and I'll keep another one for a spare, and I've ordered 2, right? So we've got one coming for this end. So we can assemble this end here anyway. This is with the fixed joint. This is the end that's going to go onto the actual gearbox. This is our adapter that we made here. There's bolts to go on there that have been cut down in length from a previous application. Guess why the scales are there and one bolt's sitting there? You need to balance the bolts as well, right? If they're out of balance, problems are going to happen. So that's 49 grams according to those scales, probably half a gram accuracy, I guess, and so are the rest of them. That one's 48. So I'm not going to put weight on there. I'm going to get the grinder out and trim all those down so they're all the same. And then we'll know that it's balanced. Cool. 48. 48. You're all waiting for one to measure something different, aren't you? That'd be funny. Then there'd be one would be 47. I'd be, oh no. Now I'm going to take another gram off all of the other ones. Bingo! You'd assume these are right. If they're not, it's probably just dirt on there. 12 grams. Duh. Look, now you can tell everyone you saw Glenn at the lab with scales and coke measuring grams. Eesh. Right, I'll just put all these things and stick that onto there. Yay! Mint! It's a thing of beauty. I've tested it in the car and we're good. We're not going to hit anything, so that's fine. I didn't think we would anyway. I still need to do something with this end here. I might temporarily put this one back together and smash it on there and just check that we are still kosher with run out and all that sort of carry on. I can't see why it would have changed, but let's just check it anyway. Look at that, it fits. Is anyone surprised? You shouldn't be. Sometimes I know what I'm doing. Sometimes. At least our angles are looking heaps better than what they used to be. So there is an angle there. It's not significant. And a little bit higher on that one because the gearbox is ever so slightly downhill, but more or less straight to the car. So much happier with that. That's far less likely to play explodey games. The lighting might be a little bit poor in there. Actually, those balls look like they're falling out, but they're nowhere near it. They're quite a long way inside that cage. That's what happens when there's no grease in there, eh? All that noise. I do have to make this again. I will make that about 5mm longer. This shaft was going to be, whatever it was, 760 or something. Flange to flange, I made it 755 to give me a little bit more room to deal with the dust cap, I guess you call it, on the back side of this, so it doesn't get crushed on the big Allen key bolts, that cap bolts that go into the shaft in there. So those will end up pretty much smack bang in the centre of where they need to run, which is great. She's going to make a lot of noise. CV joints, there's always just a tiny little bit of play in them. So clack clack from that, clack clack from the transfer box, clack clack from the diff. It's going to sound like an explosion when you change gear. That's alright, that's fine, it'll handle it. Cool! Well, I mean, technically, right at this very point in time, if I put the battery in it, and put it on the ground, it would move under its own steam. But we're not going to do that just yet. We'll get all this finished up and do it properly. Out with the old DTI again. It's too bright for you guys, isn't it? Never mind, that's on 0. I was a bit concerned. I was turning the shaft around and I was seeing 1.5 to 2. I mean 0.15 to 0.2 millimeters of run out. I was like, not happy with that. That's actually quite high. And then I put things into perspective by checking how much play there was in a basically brand new CV joint. Yeah, I think I'm probably being a little bit too fussy. Should be right. It's good. Bearing in mind that shaft moves within the joint up to 0.2. You can see where I stop it, kind of moves it a little bit. I'd say we're within 0.1, aren't we? Quite safely within 0.1. 3 thou. That's beautiful. I'm happy with that. So, wait for a boot, put that end together, get it balanced up. That's that sorted. It's actually getting a bit hot and I've had enough. And it's 4:30, so let's have an early day. Thanks for watching. Fun times coming. As soon as we get out of the levels where I can't go into the dyno shop while the car's being... Let me make a phone call on that, actually. But I don't think I can go into the dyno shop while the car's being tuned. We're not far away from being ready to set everything up. We've got a shift cut knob coming. So once we've got that, and the thermostat, which should have been here today, but it wasn't. Curious, whatever. So get the thermostat and make sure the engine's actually running to the right temp. Shift cut knob, set up the gear position indicator, etc. And we're basically at the point where we can get it on dyno and see how it goes. Alright, cheers for watching. Thanks, bye.